Hello guys and welcome back to the SimpliCode programming channel. This is Vikesh and let's get started with today's topic, which is about thread synchronization in Java. So in the previous example, we saw that when we execute threads, then we can't guarantee the sequence, but it's actually technically not a problem in the example which we had a look at before, but it can become a bigger problem when two threads are trying to access the same object. Remember, object has properties and state. So what if the first thread modified the object state and the second thread is reading the state of the object? The second thread is expecting the original state, but while it was trying to read it, the other thread modified its state. So you can see this can become a big problem. For example, if you are working with a banking system and if there are two persons accessing the same account at the same time, one is depositing the money and one is withdrawing the money from the account, and if the total balance is 1000 and if both of them deposit 500 and withdraw 500 at the same time, then who sees what? And if these are handled by two different threads, then we can't guarantee if somebody sees a 1500 as the total sum or somebody sees a 500 as the total sum, or there can be a scenario where somebody sees 0 as the total sum. So the application can turn into really weird scenarios if two threads are trying to change the state of a particular object at the same time. And Java provides a solution of it with the concept of intrinsic locks and synchronizations. So the idea is that when a thread tries to work on a particular object, it basically takes a lock on that particular object. We also call this as an intrinsic lock or monitor lock. So it takes a lock on the object, and it means that that particular object becomes completely inaccessible to other threads in the system at that particular time. So the moment you put synchronization or you put lock on a particular object, only the thread which has taken the lock will be able to access the object, and other threads will be forbidden from accessing the object. So that's the idea behind intrinsic locks and synchronization. So that was about the brief theory of it. Now let's have a look at a practical example. So I have prepared another example for it. So here I have again created two threads, but these two threads, it's pretty much the same threads which we covered in the previous session, named as thread 1 and thread 2. One is extending thread class and other is implementing runnable. But that's same, but the interesting part is this. Both of them have a reference to a class called mathutils. If you see, thread 1 also has the reference and thread 2 also has the reference. And what the mathutils is doing here is basically you supply a number and it prints the multiples of it till 5. So for example, if you supply 2, you will get the output 2, 4, 6, 8, 10. If you supply 3, you will get the multiple of 3 up to 3 times 5. So 3, 6, 9, 12, 15. If you supply 4, you will get the outputs in the multiples of 4 till 20. So whatever number you will supply, you will get the next 5 multiples of that particular number. That's what this class is doing. And another thing, interesting thing which I've done here is this thread.sleep, which means that when you run this loop where you are printing the multiples till 5 of that number, every time you do the first multiplication, then you sleep for 400 milliseconds. And when I say sleep, it basically means the current thread is going to pause its execution for 400 milliseconds, and it is going to leave the CPU idle. And if there is another thread running currently in the system, that thread will get the share of the CPU for that 400 milliseconds. And once the 400 milliseconds is finished, the thread is going to wake up and it is again going to hunt for the idle CPU to pick up and start doing its execution. So that thread.sleep happens for 400 milliseconds at every step of this iteration in this for loop. So thread 1 is going to use this particular method of this particular class, and it is going to ask the class to print the multiples of 2, and thread 2 is also going to access the reference of the class and access the get multiples method, but this thread asks to print the multiple of 3. So thread 1 asks for printing the multiples of 2 up to 2 times 5, and thread 2 wants to print the output to multiples of 3 up to 3 times 5. So that's the basic scenario. Two threads accessing the same object, supplying different values and expecting the output. So if I run this demo as is without any change, here I'm just initializing the mathutils class, initializing two threads, and then calling the start only once. So if I run this particular program, I see this strange output that even when I said T1 dot start first, so T1 was holding the multiple of 2, remember, but I still get 3 first, then 2, then 4, 6. So multiples of 2 gets executed here, but then the other thread takes the CPU and it starts running its own multiples outputs. And you see 9 printing first, and then 6 gets printed, then 12, then 8, then 15, and then 10 at very last. So the output looks very random. It would have been nicer if I could have seen 2, 4, 6 at 10 once, and then 3, 6, 9, 12, 15 once. If I see them in different sections, in different sequences, that would have been so nice, because then I know which thread is running when and when that particular thread is working on the object. So I'm just trying to replicate the same scenario where two threads are accessing the same object at the same time, but they are executing the object randomly. They're changing the state of the object randomly here. So how do we fix this? To fix this, we can so we have this get multiples method, which is the bone of contention here. This is the method which is being randomly accessed. So what I can do here, that I can put synchronized keyword in front of the method. So once you put the synchronized keyword in front of the method which is being accessed by multiple threads at the same time, this whole method gets synchronized now. What this means, that one thread will be execute this method at once. There will never be a scenario where two threads are simultaneously executing this get multiples method, or even getting a hold of this get multiples method at the same time. There would be only one thread at a time executing this method. So if I put the synchronized here, and if I rerun this example, you see I get a more streamlined output. If you notice, everything is running like clockwork, where first the thread 1 gets executed. So I get 2, 4, 6, 8, 10, really well printed. And then the second thread starts, which says 3, 6, 9, 12, 15. The reason I get this output is because when I did t1.start, it immediately went to execute the get multiples method, but it saw synchronized there. So it took a lock on the method. And even when the t2.start might have got executed, maybe milliseconds after that or nanoseconds after that, it still could not get hold of the get multiples method, because thread 1 occupied this particular method. It took a lock on this particular method due to the synchronized keyword. So that's the power of synchronized keyword, that you can take a lock on a particular method if you put it in front of the method. Now there can be scenarios that you do not want to lock the whole method. You still want two different threads to access the method, but there can be very few lines of code inside the method which is thread sensitive code. Now, how do you spot thread sensitive code? There is no magic bullet, there's no silver bullet for it, and it comes with experience. So you need to have that experience to know which is the thread sensitive code which can create problems if two threads run that code at the same time. So the moment you have spotted that code, and if you don't want to lock the whole method, you can lock the exact lines of code by putting the synchronized block. So if I remove this and I enable this particular part, so what I'm doing, that I know that this is the code which is exactly causing the problem, which is creating this random output. So what I can do, that I can put the synchronized keyword right before the block of the code starts, which is thread sensitive. And the way you do that is you write synchronized and you supply this, which means whoever has the whoever has the object of the math utils, that whole object gets logged for this particular block of code. So whoever has the math utils object takes the lock on the object for this particular block of code. If there was some other code which was written in the get multiples method before the synchronized block or after the synchronized block, that block can be accessed by multiple threads at the same time. But this code will only be accessible to one thread at a time. There will never be a concurrent access to the synchronized block. That's the power of synchronized block, and it will work the exact same way. So to show you, if I run this particular program, I still get the output in the same streamlined way, where first the multiples of 2 get printed and then the multiples of 3 get printed. So that's how you can actually use synchronized methods or synchronized block to make sure that one thread is accessing a sensitive object at a time, and there will never be a scenario that two threads are mutating the same object at the same time. Again, like I said, be very, very cautious of when you use synchronized blocks and when you use threads, because threads have unpredictable execution sequence basically, and synchronized blocks also have problems. If you have thousands and thousands of threads running in your application, and if you put synchronized on a particular method, your application may face severe performance issues because all of the threads will be executing that method in a sequence. Imagine you put this onto a huge application or a huge e-commerce application or a news website. It is going to create serious performance issues. So be very cautious of how and when you use synchronized method. And the key to that is to have that developer DNA to spot the code which is causing this problem, which might be thread sensitive. And maybe you might need to change the code itself. You might not need to go into the multi-threading scenario, and you might be able to fix it without using the threading or synchronized concept. It completely depends. But always have a good trade-off of when to use the synchronized methods and synchronized blocks. And that's all I want to cover for this particular session. And in the next session, we are going to talk about autoboxing in Java. If you like this video, a thumbs up would be massively appreciated. And please don't forget to subscribe to SimpliCode for more programming related videos. Thank you, and we'll meet again in the next session.